Hi, this is Alex from Alex's World of Math, and today we're going to be going over combinations. All right, so what if you had 8 different books and you want to choose four of them to place on a shelf? Now, how many different groups of 4 books can you select? And notice that this is different from how many ways can you arrange the books into 4 books on a shelf. Because when you say groups, um, we're basically saying that if you had like book one, book three, book five, and book two, excuse me, um, as one, one way of putting them on a shelf, that's going to be the same group as if you had book two, book one, book three, and book five. If you place like this, they're going to be counted as the same group, right? So these two ways are going to be counted as one way, as the same way. Um, and so this is slightly different from the permutations where we counted all orderings, so this is going to be less. But how do we account for um, this change that ordering does not matter? Well, first off, let's notice um, that if we counted the total number of permutations, how many ways you can arrange these 4 books, then we can try to like um, subtract or divide from that whole to get our total number of ways, where in which ordering does not matter. So, like, say you had, all right, so you have 8 books here, right? You have 8 books, and um, and each of these books are going to be distinct, and you want to find how many groups you can select. Um, so let's pass this down into permutations. How many total number of ways you can arrange arrangements. It could be arrangements or orderings. Both of them work. And notice that group. Um, I mean, sorry, not notice. I want you to know that groups. If you say groups, or you know, if or different groups, or like or sets, then those are both combinations. Uh, like when you see groups or sets, then order does not matter because sets has the same behavior as this. If you have a set like this, that's going to be equal to the set like this. That's the definition of a set. That order does not matter. And so if you wanted to place 8 books into groups, we can first split the 8 books into permutations, number of total arrangements. And so then that can be broken up into um, into um, group one, group two, group, you know, group X. Um, is going to have X uh, groupings, X groups, and our job is to, or our task is to find this X, because we want to find how many different groups can be made, right? And so this is going to be our answer. But in each group, um, in each group, we know that there's going to be some amount of ways to rearrange the 4 books, right? Um, you know, this number of ways to arrange 4. So if we wanted to find this middle part, how many groups there are, then we can use the multiplication principle again, right? Like this, passing through this, there's going to be blank space, choices, or blank number of ways to arrange the books. You're going to have X number of ways to put into groups. And this is going to have, P and comma K ways. Actually, that doesn't matter. We're not looking at that. So from the permutations, you have X groups that can be made, and in that X groups, number of ways to get the permutations into X groups, and then into this blank amount of ways to arrange for each group. And so notice that this entire thing is going to be P and comma K. And so basically we want to find this blank so that because we know that P and comma K is equal to X times blank. And so if we found blank, then we can, have P and comma K over blank is equal to X. So we can find X if we found the blank. And why does this work? Because, all right, so the permutation gives the total number of arrangements, right? But if we found the total number of groups that it can be made, and then for each group, if we multiplied that by the number of arrangements that can be made in each individual group, that's gonna all add up to the total number of arrangements, right? That's splitting the arrangements up into different groups and then finding how many arrangements each group can have. And that's naturally going to add up to the total number of arrangements. And so that's why we can use the multiplication principle here to find that P and comma K is equal to X times blank. And how do we find blank? That's the question. That's the key question here. And it's important to notice that you're choosing from four books, right? And in this case, N and K are 8, 2, 8, 4. And so how do we find the blank? So the blank is how many ways to arrange the 4 books. And so say you had book 1, book four slots for the books, right? This is the first book that you're gonna put. Let's put them in slots again. Slots 1, 2, 3, 4. How many ways to arrange 4 books? Because we already chose the books, and because we formed the group, we want to find how many ways. Like we already formed the group of 4 books, and we want to find with these 4 books, say like B1, B2. These are not like these can be any books. B4. Yeah, 4 books. These can be any of the 8 books. It doesn't it's not defined by like these B1. This B1 is not a specific book. It's possible books. Um, you're basically saying if you chose or if you already chose this for one of the groups, then let let the uh, let the first book be named that you choose be B1, arbitrary book. And so you're gonna have 4 arbitrary books that you want to arrange into 4 slots, right? You want to see how many arrangements you can make with those 4. So you're placing 4 books into 4 slots. And we also know that that's basically permutations, right? You have 4 options for the first one. If you pick one book, then you have 3, 2, 1. And so this is just using permutations. You have 4 factorial. And so the number of arrangements of 4 books into 4 spots is going to be 4 factorial. So the blank is 4 factorial. Therefore, x is equal to, what is P 8, 4? well, that's we can use the formula. It's a factorial over 8 minus 4 factorial, which we found in another one. Another example is going to be 1680. I mean, yeah, 1680. Um, and you're dividing all this by 4 factorial that we just found as the arrangements. Um, 4 factorial is equal to 1680 over what is 4 times 3 times 2 times 1? That's equal to 12 times. That's going to be 24. And so if you divide by 24, I believe this is like 70, I think. 70 ways. And so that's going to be our answer. You have 70 ways to do so. And notice that this can be concluded for any n comma k instead of 8 comma 4. If you just replace the 8 and 4, then you're going to get normally for any n comma k, you can form how many groups can be formed. Let's know that by x. Instead of x, we can just write number of possible groups, or you can say groupings, or sets from n. You have n books. Um, instead of n books, and then so the number of possible groups is going to be equal to p n comma k over k factorial, right? Because k factorial gives how many orderings can be arranged after choosing k items. And so this is actually going to also equal to the combinations, number of combinations. This is known as combinations. And so normally people also say how many ways to choose 4 books, choose groups of 4 books. And another notation is NK. This reads and choose K. Um, and yeah, if you want to see it, more direct here, here's the definition. And yeah, so let's apply that to a quick problem here. So remember when I said sets, all sets are unordered. So choosing sets are also the same thing as choosing groups. So this is combinations. How many subsets of size 5 can be formed from cardinality of size, a cardinality or size of 9. And also repetitions are not allowed in sets. As I said before, sets only have distinct items. And so if you want to choose subsets of 5, that's basically saying how many you want to choose groups of size 5 from a set of size 9. And so that's the same thing as our books, right? We have 9 books. We want to choose 5. You want to choose groups of size k. So in this case, we have 9 a set of 9 quote unquote books, and we want to choose a we want to find how many groups can be made from of size 5 from that many books. So that's going to be C 9 5 or 9 choose 5, and 9 choose 5 is the more common notation. N choose K. And this is going to be equal to 9 factorial over n factorial n minus k factorial. Oh, I'm sorry. Um, uh, 9 minus 5 factorial times 5 factorial. Because remember, this is equal to p n comma k over k factorial, and we know that that's also equal to n factorial over n minus k factorial over k factorial, which is also just equal to that times k factorial. And so that's going to give us this. And so it's going to be 9 factorial over 4 factorial times 5 factorial. which is also equal to 9 times 8 times 7 times 6 times 5 factorial over 4 factorial times 5 factorial. The 5 factorials cancel out. And 4 factorial is also equal to 4 times 3 times 2 times 1. And so the 4 and 2 can be canceled out with 8. 3 can be canceled out with 6 to get 2 on top, because 6 is 3 times 2. Our answer is equal to 9 times 7 times 2, which is 14 times 9. And that's going to be equal to 126 ways. And so yeah, that's how you use the combination formula to solve a problem. All right, that's all. Have a nice day.